Hello, mathletes. So, section 4.2, we're going to prove that triangles are congruent by two postulates, SSS, which stands for side, 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 and SAS, which stands for side, angle, side. So these are two congruence postulates for triangles, and we'll see if a couple more as well in the next couple sections. So, side, side, side. So what this says, as its name states, that if three sides of a triangle are congruent to three sides of another triangle, then that means that the two triangles are congruent. Okay? So here, if AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF, if all three sides of this triangle are congruent to all three sides of this triangle, that means the triangles must be congruent, right? So in other words, all the angles must be the same as well, right? All the parts of each of those triangles are the same. Okay, so in the last lesson we were proving that all the parts were the same in order to prove that that shapes were congruent. But with triangles, if you can prove the three sides are congruent, then that's enough to say that the triangles themselves are congruent, right? So all the corresponding parts are congruent. So then that leads us to once we can prove that they're congruent, then we can say, okay, well, that means angle A corresponds with angle D, so they must be congruent, and B must be congruent to E, and C, since it corresponds with F, must be congruent to F, right? So once you find the three sides are congruent, you can use that to conclude the other parts are congruent. So the other postulate that we're working with in this section is side, angle, side, so SAS. So this says if two sides and the included angle, okay, so the included angle, that's an important aspect of this. The included angle is the angle between the two sides, right? So you have two sides and the angle in between them, okay? And it's just like the title says, side, angle, side, right? So it has to go in that order. So here we have another side, angle, side, right? So if two sides in the included angle of one triangle are congruent to two sides in the included angle of another triangle, then the two triangles are congruent. Okay, so once again, we don't have to prove that every single angle and every single side is congruent. It's enough to say, okay, if we can get two sides in the included angle of two different triangles, if we can prove that they're congruent, then that means that the two triangles themselves are congruent. And so that means that in addition to what we already know is congruent, angle F would be congruent to angle C, angle E would be congruent to angle B, and side EF would be congruent to side BC, right? All right, so basically we're narrowing down the information or the parts that we have to prove congruent, and so we're finding a more efficient way to prove triangles congruent. Instead of proving every part, we can do three sides congruent, or we can do two sides in the included angle. Okay.